Hello, let us see how to solve this particular problem. So basically, if you see here, there is a digital to analog converter given, which is R-2R based, and then the reference voltage is provided and the resistance have been given. So we have to calculate the output voltage. So to calculate the output voltage, before going to calculate the output voltage, we can divide this circuit into two sections. One is R-2R ladder, and the second one is a I2V converter. I2V converter. So I2V converter is nothing but which converts the current that is flowing into this into a output voltage. So these are the two ingredients of this digital to analog converter. So to calculate the output voltage, basically we need to know the current that is flowing here, okay, which will be I. Let us treat it as I because it is a non-inverting terminal. We can say V0 is equal to minus I into R. Okay, so R is already given as 10K. I is what we have to calculate, and V0 is what will be getting the output. So to calculate I, we have to know I1, and then we have to know I2 because these are the two nodes from which the current will be input to the op amp. So that means here I is got by I1 plus I2. Okay, so these are the two currents that will be coming out of these nodes. Now we have to calculate the I1 and I2 currents. So for this we have to take this R2R ladder and get to know how the current is flowing. So before going to this R2R ladder, there is one concept in op amps called the virtual ground. So as per the virtual ground concept, if one of the input terminal is grounded, then the other terminal is also treated as a 0 volts. So that means ground. So which is basically an ideal case. So that means we can treat this node as a ground. If this node is treated as a ground, so we can say this is also ground and this is also ground. So the equivalent circuit of this two R2R can be represented this way. Okay, R, and then there will be 2R. So here we represented this as a ground here. That's what you see here, and then you have R2R again, and again this anyway is a ground already, and again you have R2R. Okay, and now you have a 2R. So here it is given as I. So this is how the equivalent R2R circuit can be represented as. Now if you see here, this is a simple voltage and a resistance based circuit where you need to calculate the equivalent resistance and then calculate the current that is flowing into that circuit. So now to calculate the equivalent resistance, let us start from the end. So if you see here, this is nothing but 2R and 2R are in parallel. That means it will be R. So if you see, that means the R will be to ground, which is the equivalent of this. So now R plus R will be 2R to ground. So again 2R, 2R, this will be R here again. So again R plus R, 2R, 2R and 2R parallel. This will be R again. R plus R, 2R, 2R and 2R parallel, which will be R. That means this circuit can be simply represented as this VR. So now let us consider the current into this node. So now it is given as I here. So because this is 2R, this is 2R, both are same resistance, this will be I here. As per Kirchhoff's current law, this will be 2I because I gets divided equally between equal loads. So 2I is I plus I. So if this is 2I, this is 2I. If this is 2I, we know this equivalent is 2R. So again this is 2I. So the advantage of this R2R ladder is it is symmetric. So you can just go ahead adding this 4I. Again this will be 4I, and then this will be 8I. Because 4I plus 4I, this will be 8I, and this will be 16I. So that means the current here will be 16I. So VR is nothing but 16I into R. So calculator 16I into R. So VR is given as 10, 16I into 10K, right? So 10K if you take here, this will be 16I is equal to 1 milli. Okay, so that means I is equal to 1 by 16 milliamps. Okay, so this is the total current that will be coming out into this R-2R, because this is I. So here now from here you can calculate I1, because I1 is nothing but, if you see 4 into Y, so that means 4 into 1 by 16, which is nothing but 1 by 4 milliamps. Okay, now I2 if you take I2 is this is I, you can see here I2 is this last 2R, so this is nothing but I, so directly it is 1 by 16 milliamps. As said here, I is equal to I1 plus I2, which is nothing but 1 by 4 plus 1 by 16 total milliamps. Okay, which is nothing but 5 by 16 milliamps. So if you do V0, I is here minus I is 5 by 16. So as this is a inverting terminal, and this is actually we treated it as a ground, but the current will be in reverse. So minus 5 by 16 M into 10K, because R is given as 10K here. Okay, so if you cancel this away, which gives so minus 16 by 5 is 0 0.00, 16 3 is 48, uh, 48 to and so 0.48, 2 will come, 1, 61, 16, 4, 16, 3, 16 2s, okay, 2, 0.012 into 10, right? Because 10 is here, K and M we calculate, so that means 0.312 amps will be the current that will volts that will be flowing into this the total voltage of this, right? Or 0.5 by 16, 0. This is not 0.0, 0.312 into 10, which means 3.12 volts. Okay, so the total voltage, output voltage for this given circuit of VR and 10 would be 3.12 volts. So you can see there are different things that you need to do here. So such problems are very good problems where you need to apply the technical skills as well as the analytical skills, and sometimes you need to think how to approach such problems. Thank you.